This dirty ST9019 Deutsch harness got a 1-star review on Amazon titled Fire Hazard. The buyer says she used it on an air ride suspension, and after about a month, the harness caught fire, burned the seat, and burned her husband's hand. We never treat a fire-related 1-star review as just another comment to scroll past. In this video, we're not testing yet. We're going to do one thing. Break this review down and figure out how much is product related and how much is about usage and selection. The detailed current and temperature test will be in the next standalone test video. Let's break this review into pieces instead of staring only at the word fire. First point, air ride system. This tells us the ST9019 harness wasn't powering a small light, but was wired into the air suspension system circuit. Very likely, supplying power to the air compressor or solenoid valves. In an air suspension system, there is usually a 12V air compressor. The operating current of this type of compressor is typically more than 10 amps, and some can even reach 20 amps or higher at peak. Second point, after a month of use. This means the wiring worked at first. It's not an instant short or reverse polarity. It's a risk that built up over time. Third point, the back of my seat. The fire was near the back of the seat. That's often where people tuck wires under the seat or behind the backrest for convenience. Seat foam is quite flammable. A wire that runs too hot carbonizes the insulation, and then arcs can easily ignite that foam. Next, let's look at what the ST9019 is actually designed for. It uses 14 ALG tinned copper wire with a 2-pin Deutsch DT waterproof connector, rated IP67, rated current of 13A. Typical use cases are light glass and other medium 12V loads. In this review, all the keywords point in one direction: high current load plus cramped seat area plus failure after some time in use. This doesn't mean the customer is exaggerating or using it wrong. On purpose, the fire they experienced is real and serious, and we have to treat it that way. What we want to highlight is, from one review, you can't see the entire wiring design, but from what we do know, this looks like a mismatch between harness rating, load size, and routing method. Finally, here are 5 very practical tips for everyone who's into car mods or electrical projects. First, size your harness to your load. Find out the device's operating current and peak current first, and then select the wire gauge and connectors. As a general rule, it's recommended that the rated current of the harness and connectors and connectors be 1.5 times the actual operating current. Second, make sure crimping and waterproof connections are done properly. Use a dedicated crimping tool plus heat shrink waterproof terminals. After crimping, you must perform a simple pull test. If you can't pull it loose or break the wire, that is qualified. Third, use dedicated runs, larger wire gauge, and relays for high currents. Loads like compressors really deserve a 10-12 AWG dedicated circuit with a relay, instead of forcing a single 14RG harness to carry everything. Fourth, the wiring environment is also very important. In the hot, confined environment inside a vehicle, you should avoid bundling all the harnesses into one big bundle. Fifth, regularly inspect modified circuits. If you smell something odd or feel a connector getting hot, you should immediately inspect it or stop using it. If you've run into a similar problem, feel free to let us know in the comments. We can run a dedicated test for your specific scenario. In the next video, we'll do actual measurements of the ST9019 under different current levels. If you're interested in this kind of testing, please subscribe to the channel, and we'll see you next time.